The Biology of Belief by Bruce Lipton, Ph.D. Chapter 5, Biology and Belief. In 1952, a young British physician made a mistake. It was a mistake that was to bring short-lived scientific glory to Dr. Albert Mason. Mason tried to treat a 15-year-old boy's warts using hypnosis. Mason and other doctors had successfully used hypnosis to get rid of warts. But this was an especially tough case. The boy's leathery skin looked more like an elephant's hide than a human's, except for his chest, which had normal skin. Mason's first hypnosis session focused on one arm. When the boy was in a hypnotic trance, Mason told him that the skin on the arm would heal and turn into healthy pink skin. When the boy came back a week later, Mason was gratified to see that the arm looked healthy. But when Mason brought the boy to the referring surgeon, who had unsuccessfully tried to help the boy with skin grafts, he learned that he had made a medical error. The surgeon's eyes were wide with astonishment when he saw the boy's arm. It was then that he told Mason that the boy was suffering not from warts, but from a lethal genetic disease called congenital ichthyosis. By reversing the symptoms using only the power of the mind, Mason and the boy had accomplished what had until that time been considered impossible. Mason continued the hypnosis sessions with the stunning result that most of the boy's skin came to look like the healthy pink arm after the first hypnosis session. The boy, who had been mercilessly teased in school because of his grotesque-looking skin, went on to lead a normal life. When Mason wrote about his startling treatment of ichthyosis, the British Medical Journal in 1952, his article created a sensation. Mason was touted in the media and became a magnet for patients suffering from the rare lethal disease that no one before had ever cured. But hypnosis was in the end not a cure-all. Mason tried it on a number of other ichthyosis patients, but he was never able to replicate the results he had had with the young boy. Mason attributes his failure to his own belief about the treatment. When Mason treated the new patients, he couldn't replicate his cocky attitude as a young physician, thinking he was treating a bad case of warts. After the first patient, Mason was fully aware that he was treating what everyone in the medical establishment knew to be a congenital, incurable disease. Mason tried to pretend that he was upbeat about the prognosis, but he had told the Discovery Health Channel, "I was acting." How is it possible that the mind can override genetic programming, as it did in the case above? And how could Mason's belief about that treatment affect its outcome? The new biology suggests some answers to these questions. We saw in the last chapter that matter and energy are entangled. The logical corollary is that the mind, or energy, and body, or matter, are similarly bound, though Western medicine has tried valiantly to separate them for hundreds of years. In the 17th century, René Descartes dismissed the idea that the mind influences the physical character of the body. Descartes' notion was that the physical body was made out of matter and the mind was made out of an unidentified but clearly immaterial substance. Because he couldn't identify the nature of the mind, Descartes left behind an irresolvable philosophical conundrum. Since only matter can affect matter, how can an immaterial mind be connected to a material body? The non-physical mind envisioned by Descartes was popularly defined as the ghost in the machine by Gilbert Ryle 60 years ago in his book, The Concept of Mind. Traditional biomedicine, whose science is based on a Newtonian matter-only universe, embraced Descartes' separation of mind and body. Medically speaking, it would be far easier to fix a mechanical body without having to deal with its meddling ghost. The reality of a quantum universe reconnects what Descartes took apart. Yes, the mind, or energy, arises from the physical body, just as Descartes thought. However, our new understanding of the universe's mechanics shows us how the physical body can be affected by the immaterial mind. Thoughts, the mind's energy, directly influence how the physical brain controls the body's physiology. Thought, or energy, can activate or inhibit the cell's function-producing proteins via the mechanics of constructive and destructive interference, described in the previous chapter. That is why, when I took the first step towards changing my life, I actively monitored where I was expending my brain's energy. I had to examine the consequences of energy invested in my thoughts as closely as I examined the expenditures of energy I used to power my physical body. Despite the discoveries of quantum physics, the mind-body split in Western medicine still prevails. Scientists have been trained to dismiss cases like the boy above, who used his mind to heal a genetically mandated disease, a quirky anomaly. I believe, on the contrary, that scientists should embrace the study of these anomalies. Buried in exceptional cases are the roots of a more powerful understanding of the nature of life. More powerful because the principles behind these exceptions trump established truths. The fact is that harnessing the power of your mind can be more effective than the drugs you have been programmed to believe you need. The research I discussed in the last chapter found that energy is a more efficient means of affecting matter than chemicals. Unfortunately, scientists most often deny rather than embrace exceptions. My favorite example of scientific denial of the reality of mind-body interactions relates to an article that appeared in Science about 19th century German physician Robert Koch, who, along with Pasteur, found the germ theory. The germ theory holds that bacteria and viruses are the cause of disease. That theory is widely accepted now, but in Koch's day, it was more controversial. One of Koch's critics was so convinced that the germ theory was wrong that he brazenly wolfed down a glass of water laced with Vibrio cholera, the bacterium Koch believed caused cholera. To everyone's astonishment, the man was completely unaffected by the virulent pathogen. The Science article published in 2000 described the incident, stated, and unexplained reasons, he remained symptom-free, but nevertheless incorrect. The man survived, and Science, reflecting the unanimity of opinion on the germ theory, had the audacity to say his criticism was incorrect. If it is claimed that the bacterium is the cause of cholera, and man demonstrates that he is unaffected by the germs, how can he be incorrect? Instead of trying to figure out how the man avoided the dreaded disease, scientists blithely dismiss this and other embarrassing, messy exceptions that spoiled their theories. Remember the dogma that genes control biology? Here is another example in which scientists, bent on establishing the validity of their truth, ignore pesky exceptions. The problem is that there cannot be exceptions to a theory. Exceptions simply mean that a theory is not fully correct. A current example of a reality that challenges the established beliefs of science concerns the ancient religious practice of firewalking. Seekers gathered together daily to stretch the realms of conventional awareness by walking across beds of hot coals. Measurement of the stone's temperature and duration of exposure are enough to cause medically relevant burns on the feet, yet thousands of participants emerged from the process totally unscathed. Before you jump to the conclusion that the coals were not really that hot, consider the number of participants who wavered in their beliefs and get scalded walking across the same bed of coals. Similarly, science is unambiguous about its claims that the HIV virus causes AIDS, but has no conception as to why large numbers of individuals that have been infected with the virus for decades do not express the disease. More baffling is the reality of terminal cancer patients who have recovered their lives through spontaneous remissions. Because such remissions are outside the bounds of conventional theory, science completely disregards the fact that they ever happened. Spontaneous remissions are dismissed as unexplainable exceptions to our current truths or simply misdiagnosis. When positive thinking goes bad. Before I go on to discuss the incredible power of our minds and how my research on cells provided insight into how the body's mind-body pathways work, I need to make it very clear that I do not believe that simply thinking positive thoughts always leads to physical cures. You need more than just positive thinking to harness control of your body and your life. It is important for your health and well-being to shift the mind's energy towards positive, life-generating thoughts and eliminating ever-present, energy-draining, and debilitating negative thoughts. But, and I mean that in the biggest sense of but, the mere thinking of positive thoughts will not necessarily have an impact on our lives at all. In fact, sometimes people who flunk positive thinking become more debilitated because now they think their situation is hopeless. They believe that they have exhausted all mind and body remedies. What those positive thinking dropouts haven't understood is that the seemingly separate subdivisions of the mind, the conscious and the subconscious, are interdependent. The conscious mind is a creative one, the one that can conjure up positive thoughts. In contrast, the subconscious mind is a repository of stimulus response tapes derived from instincts and learned experiences. The subconscious mind is strictly habitual. It will play the same behavioral responses to life signals over and over again, much to our chagrin. How many times have you found yourself going ballistic over something trivial like an open toothpaste tube? You have been trained since childhood to carefully replace the cap. When you find the tube with its cap off, your buttons are pushed, and you automatically fly into a rage. You've just experienced the simple stimulus response of a behavior program stored in the subconscious mind. When it comes to sheer neurological processing abilities, the subconscious mind is millions of times more powerful than the conscious mind. If the desires of the conscious mind conflict with the programs in the subconscious mind, which mind do you think will win out? You can repeat the positive affirmation that you are lovable over and over, or that your cancer tumor will shrink. But if, as a child, you heard over and over that you are worthless and sickly, those messages programmed in your subconscious mind will undermine your best conscious efforts to change your life. Remember how quickly your last New Year's resolution to eat less food fell by the wayside as the aroma of the baking turkey dissolved your resolve? We'll learn more about the origins of self-sabotaging subconscious programming in Chapter 7, in Conscious Parenting, and how to quickly rewrite them. But for the moment, be aware that there is hope, even for those of you who used positive thinking and failed miserably. Mind over body. Let's review what we know about cells. We learned in earlier chapters that the functions of cells are directly derived from the movements of our protein gears. The movement generated by assemblies of proteins provides the physiological functions that enable life. While proteins are the physical building blocks, complementary environmental signals are required to animate their movement. The interference between environmental signals and behavior-producing cytoplasmic proteins is the cell's membrane. The membrane receives stimuli and then engages the appropriate life-sustaining cellular responses. The cell membrane operates as the cell's brain. Integral membrane receptor effector proteins, or IMPs, are the fundamental physical subunits of the cellular brain's intelligence mechanism. By functional definition, these protein complexes are perception switches that link reception of environmental stimuli to response-generated protein pathways. Cells generally respond to an assortment of very basic perceptions of what's going on in their world. Such perceptions include whether things like potassium, calcium, oxygen, glucose, histamine, estrogen, toxins, light, or any number of other stimuli are present in their immediate environment. The simultaneous interactions of tens of thousands of reflexive perception switches in the membrane, each directly reading an individual environmental signal, collectively create the complex behavior of a living cell. For the first 3 billion years of life on this planet, the biosphere consisted of free-living single cells such as bacteria, algae, and protozoans. While we have traditionally considered such life forms as solitary individuals, we are now aware that signal molecules used by individual cells to regulate their own physiological functions, when released into the environment, also influence the behavior of other organisms. Signals released into the environment allow for a coordination of behavior among a dispersed population of unicellular organisms. Secreting signal molecules into the environment enhance the survival of single cells by providing them with the opportunity to live as a primitive community. The single-celled slime mold amoebas provide an example of how signaling molecules lead to community. These amoebas live a solitary existence in the soil, foraging for food. When available food in the environment is consumed, the cells synthesize an excess amount of metabolic byproduct called cyclic AMP, or CAMP, much of which is released into the environment. The concentration of the released CAMP builds in the environment as other amoebas face starvation. When secreted CAMP signal molecules bind to CAMP receptors on the cell membranes of other slime mold amoebas, it signals them to activate a swarming behavior wherein the amoebas congregate and form a large multicellular slug. This slug community is the reproductive stage of slime mold. During the famine period, the community of aging cells shares their DNA and creates the next generation of offspring. The new amoebas hibernate as inactive spores. When more food is available, the food molecules act as a signal to break the hibernation, releasing a new population of single cells to start the cycle over again. The point is that single-celled organisms actually live in a community when they share their awareness and coordinate their behaviors by releasing signal molecules into the environment. Cyclic AMP was one of the evolution's earliest forms of secreted regulatory signals that control cell behavior. The fundamental human signal molecules, e.g., hormones, neuropeptides, cytokines, growth factors, that regulate our own cellular communities were once thought to have arisen with the appearance of complex multicellular life forms. However, recent research has revealed that primitive single-celled organisms were already using these human signal molecules in the earliest stages of evolution. Through evolution, cells maximize the number of IMP awareness proteins their membranes could hold. To acquire more awareness and therefore increase their probability of surviving, cells started to assemble first into simple colonies and later into highly organized cellular communities. As described earlier, the physiological functions of multicellular organisms are parceled out to specialized communities of cells forming the body's tissues and organs. In communal organizations, the cell membrane's intelligence processing is carried out by the specialized cells of the organism's nervous and immune systems. It was only 700 million years ago, recent in regard to the time frame of life on this planet, when single cells found it advantageous to join together in tightly knit multicellular communities, organizations we recognize as animals and plants. The same coordinating signal molecules used by free-living cells were used in these newly evolved closed communities. By tightly regulating the release and distribution of these function-controlling signal molecules, the community of cells would be able to coordinate their functions and act as a single life form. In the more primitive multicellular organism, those without specialized nervous systems, the flow of these signal molecules within the community provided an elementary mind, represented by the coordinating information shared by every cell. In such organisms, each cell directly read environmental cues and personally adjusted its own behavior. However, when cells came together in community, a new politic had to be established. In community, each cell cannot act as an independent agent to do whatever it wants. The term community implies that all of its members commit to a common plan of action. In multicellular animals, individual cells may see the local environment outside of their own skin, but they may have no awareness of what is going on in more distant environments, especially those outside of the whole organism itself. Can a liver cell buried in your viscera respond to its local environmental signals? Make an informed response regarding the consequence of a mugger that jumps into your environment? The complex behavior controls needed to ensure a multicellular organization's survival are incorporated within its centralized information processing system. As more complex animals evolved, specialized cells took over the job of monitoring and organizing the flow of the behavior-regulating signal molecules. Those cells provided a distributed nerve network and central information processor, a brain. The brain's function is to coordinate the dialogue of signal molecules within the community. Consequently, in a community of cells, each cell must acquiesce control to the informed decisions of its awareness authority, the brain. The brain controls the behavior of the body's cells. This is a very important point to consider as we blame the cells of our organs and tissues for the health issues we experience in our lives. Emotions. Feeling the language of cells. In higher, more aware life forms, the brain developed a specialization that enabled the whole community to tune into the status of its regulatory signals. The evolution of the limbic system provided a unique mechanism that converted the chemical communication signals into sensations that could be experienced by all of the cells in the community. Our conscious mind experiences these signals as emotions. The conscious mind not only reads the flow of the cellular coordinating signals that comprise the body's mind, it can also generate emotions, which are manifested through the controlled release of regulatory signals by the nervous system. At the same time that I was studying the mechanics of the cell's brain and gaining insight into the operation of the human brain, Candace Pert was studying the human brain and becoming aware of the mechanics of the cell's brain. In Molecules of Emotion, Pert revealed how her study of information processing receptors on nerve cell membranes led her to discover that the same neural receptors were present on most, if not all, of the body's cells. Her elegant experiments established that the mind was not focused in the head, but was distributed via signal molecules to the whole body. As importantly, her work emphasized that emotions were not only derived through a feedback of the body's environmental information. Through self-consciousness, the mind can use the brain to generate molecules of emotion and override the system. While proper use of consciousness can bring health to an ailing body, inappropriate unconsciousness control of emotions can easily make a healthy body diseased, a topic I will expand on in chapters 6 and 7. Molecules of Emotion is a very insightful book describing the scientific discovery process. It also provides some revealing insight into the struggles encountered when trying to introduce new ideas into science's old boys club, a subject with which I am all too familiar with. The limbic system offered a major evolutionary advance through its ability to sense and coordinate the flow of behavior regulating signals within the cellular community. As the internal signal system evolved, its greater efficiency enabled the brain to increase in size. Multicellular organisms gained increasingly more cells that were dedicated to responding to an even wider variety of external environmental signals. While individual cells can respond to simple sensory perceptions such as red, round, aromatic, and sweet, the extra brain power available in multicellular animals enables them to combine those simple sensations to a higher level of complexity and perceive apple. Fundamental reflex behaviors acquired through evolution are passed on to offspring in the form of genetic-based instincts. The evolution of larger brains, with their increased neural cell population, offer organisms the opportunity not only to rely on instinctual behavior, but also to learn from their life experiences. The learning of novel reflex behaviors is essentially a product of conditioning. For example, consider the classic example of Pavlov training his dogs to salivate at the ring of a bell. He first trained them by ringing a bell and coupling that stimulus with a food reward. After a while, he would ring the bell but not offer the food. By that time, the dogs were so programmed to expect the food that when he rang the bell ring, they reflexively started to salivate even though no food was present. This is clearly an unconscious learned reflex behavior. Reflex behaviors may be as simple as the spontaneous kick of the leg when a mallet taps the knee, or as complex as driving a car at 65 miles per hour on a crowded interstate highway while your conscious mind is fully engaged in conversation with the passenger. Though conditioned behavior responses may be inordinately complex, they are no-brainers. Through the conditioned learning process, neural pathways between eliciting stimuli and behavioral responses become hardwired to ensure a repetitive pattern. Hardwired pathways are habits. In lower animals, the entire brain is designed to engage in purely habitual responses to stimuli. Pavlov's dogs salivated by reflex, not by deliberate intention. The actions of the subconscious mind are reflexive in nature and are not governed by reason or thinking. Physically, this mind is associated with the activities of all of the brain structures that are present in animals that have not evolved self-consciousness. Humans and the number of the other higher mammals have evolved a specialized region of the brain associated with thinking, planning, and decision-making called the prefrontal cortex. This portion of the forebrain is apparently the seat of the self-conscious mind processing. The self-conscious mind is self-reflective. It is newly evolved sense organ. It is a newly evolved sense organ that observes our own behaviors and emotions. The self-conscious mind also has access to most of the data stored in our long-term memory bank. This is an extremely important feature, allowing our history of life to be considered as we consciously plan our futures. Endowed with the ability to be self-reflective, the self-conscious mind is extremely powerful. It can observe any programmed behavior we are engaged in, evaluate the behavior, and consciously decide to change the program. We can actively choose how to respond to most environmental signals and whether we even want to respond at all. The conscious mind's capacity to override the subconscious mind's pre-programmed behaviors is the foundation of free will. However, our special gift comes with a special pitfall. While almost all organisms have to actually experience the stimuli of life firsthand, the human brain's ability to learn perceptions is so advanced that we can actually acquire perceptions indirectly from teachers. Once we accept the perceptions of others as truths, their perception becomes hardwired into our own brains, becoming our truths. Here's where the problem arises. What if our teachers' perceptions are inaccurate? In such cases, our brains are then downloaded with misperceptions. The subconscious mind is strictly a stimulus response playback device. There is no ghost in that part of the machine to ponder the long-term consequences of the programs we engage. The subconscious works only in the now. Consequently, program misperceptions in our subconscious mind are not monitored and will habitually engage us in inappropriate and limiting behaviors. If I included as a bonus in this chapter a slithering snake that pops out of the page right now, most of you would run from the room and throw the book out of the house. Whoever introduced you to your first snake may have behaved in such a shocked way as to give your impressionable mind an apparently important life lesson. See snake? Snake bad. The subconscious memory system is very partial to rapidly downloading and emphasizing perceptions regarding things in your environment that are threatening to life and limb. If you were taught that snakes are dangerous, any time a snake comes into your proximity, you reflexively or unconsciously engaged in a protective response. But what if a herpetologist were reading this book and a snake popped out? No doubt that herpetologist would not only be intrigued by the snake, they would be thrilled with the bonus included in the book. Or at least they'd be thrilled once they figured out that the book's snake was harmless. They would then hold it and watch its behaviors with delight. They would think that your programmed response was an irrational one. Not all snakes are dangerous. Further, they would be saddened by the fact that so many people are deprived of the pleasures of studying such interesting creatures. Same snake, same stimulus, yet greatly different responses. Our responses to environmental stimuli are indeed controlled by perceptions, but not all of our learned perceptions are accurate. Not all snakes are dangerous. Yes, perception controls biology, but as we've seen, these perceptions can be true or false. Therefore, we would be more accurate to refer to these controlling perceptions as beliefs. Beliefs control biology. Ponder the significance of this information. We have the capacity to consciously evaluate our responses to environmental stimuli and change our old responses anytime we desire. Once we deal with the powerful subconscious mind, which I discuss in more depth in Chapter 7, we are not stuck with our genes or our self-defeating behaviors. How the mind controls the body. My insights into how beliefs control biology are grounded in my studies of cloned endothelial cells, the cells that line the blood vessels. The endothelial cells I grew in culture monitor their world closely and change their behavior based on information they pick up from the environment. When I provide nutrients, the cells would gravitate towards those nutrients with the cellular equivalent of open arms. When I created a toxic environment, the cultured cells would retreat from the stimulus in an effort to wall themselves off from the noxious agents. My research focused on the membrane perception switches that controlled the shift from one behavior to the other. The primary switch I was studying was a protein receptor that responds to histamine, a molecule that the body uses in a way that is equivalent to a local emergency alarm. I found that there are two varieties of switches, H1 and H2, that respond to the same histamine signal. When activated, switches with H1 histamine receptors evoked a protection response, the type of behavior revealed by cells in toxin-containing culture dishes. Switches containing H2 histamine receptors evoke a growth response to histamine, similar to the behavior of cells cultured in the presence of nutrients. I subsequently learned that the body's system-wide emergency response signal, adrenaline, also has switches sporting two different adrenaline-sensing receptors called alpha and beta. The adrenaline receptors provoke the exact same cell behavior as those elicited by histamine. When the adrenaline alpha receptor is part of an IMP switch, it provokes a protection response when adrenaline is perceived. When the beta receptor is part of the switch, the same adrenaline signal activates a growth response. All that was interesting, but the most exciting finding was when I simultaneously introduced both histamine and adrenaline into my tissue cultures, I found that adrenaline signals released by the central nervous system override the influence of histamine signals that they are produced locally. This is where the politics of the community described earlier come into play. Suppose you're working in a bank. The branch manager gives you an order. The CEO walks in and gives you the opposite order. Which order would you follow? If you want to keep your job, you'll snap to the CEO's order. There is a similar priority built into our biology, which requires cells to follow instructions from the head honcho nervous system, even if those signals are in conflict with the local stimuli. I was excited by my experiments because I believe that they reveal They revealed on the single cell level a truth for multicellular organisms, that the mind, acting via the central nervous system's adrenaline, overrides the body, acting via the local histamine signal. I wanted to spell out the implications of my experiments in my research paper, but my colleagues almost died from apoplexy at the notion of injecting the body-mind connection into a paper about cell biology. So I put in a cryptic comment about understanding the significance of the study, but I couldn't say what the significance was. My colleagues did not want me to include these implications of my research because the mind is not an acceptable biological concept. Bioscientists are conventional Newtonians. If it isn't matter, it doesn't count. The mind is a non-localized energy and therefore is not relevant to materialistic biology. Unfortunately, that perception is a belief that has been proven to be patently incorrect in the quantum mechanical universe. Placebos, the belief effect. Every medical student learns, at least in passing, that the mind can affect the body. They learn that some people get better when they believe, falsely, that they are getting medicine. When patients get better by ingesting a sugar pill, medicine defines it as the placebo effect. My friend, Rob Williams, founder of Psych-K, an energy-based psychological treatment system, suggests that it would be more appropriate to refer to it as the perception effect. I call it the belief effect, to stress that our perceptions, whether they are accurate or inaccurate, equally impact our behavior and our bodies. I celebrate the belief effect, which is an amazing testament to the healing ability of the body-mind. However, the all in their minds placebo effect has been linked by traditional medicine to, at worst, quacks, or at best, weak, suggestible patients. The placebo effect is quickly glossed over in medical schools so that students can get to the real tools of modern medicine, like drugs and surgery. This is a giant mistake. The placebo effect should be a major topic of study in medical school. I believe that medical education should train doctors to recognize the power of our internal resources. Doctors should not dismiss the power of the mind as something inferior to the power of chemicals and the scalpel. They should let go of their conviction that the body and its parts are essentially stupid and that we need outside intervention to maintain our health. The placebo effect should be the subject of major funded research efforts. If medical researchers could figure out how to leverage the placebo effect, they would hand doctors an efficient, energy-based, side-effect-free tool to treat disease. Energy healers say they already have such tools, but I am a scientist, and I believe that the more we know about the science of the placebo, the better we'll be able to use it in a clinical setting. I believe the reason the mind has so summarily been dismissed is medicine is the result not only of dogmatic thinking, but also of financial considerations. If the power of your mind can heal your sick body, why should you go to the doctor? And more importantly, why would you need to buy drugs? In fact, I was recently chagrined to learn that drug companies are studying patients who respond to sugar pills with the goal of eliminating them from early clinical trials. It inevitably disturbs pharmaceutical manufacturers that in most of their clinical trials, the placebo, the fake drug, proved to be as effective as their engineered chemical cocktails. Though the drug companies insist they're not trying to make it easier for ineffective drugs to get approved, it is clear that effectiveness of placebo pills is a threat to the pharmaceutical industry. The message from the drug companies is clear to me. If you can't beat placebo pills fairly, simply remove the competition. The fact that most doctors are not trained to consider the impact of the placebo effect is ironic because some historians make a strong case that the history of medicine is largely the history of the placebo effect. For most of medical history, doctors did not have effective methods to fight disease. Some of the more notorious treatments once prescribed by mainstream medicine include bloodletting, treating wounds with arsenic, and the proverbial cure-all, rattlesnake oil. No doubt some patients, the conservatively estimated 1/3 of the population who are particularly susceptible to the healing power of the placebo effect, got better with those treatments. In today's world, when doctors wearing white coats deliver a treatment decisively, patients may believe the treatment works, and so it does, whether it is a real drug or just a sugar pill. Though the question of how placebos work has in the main been ignored by medicine, recently some mainstream medical researchers are tuning their attention to it. The results of these studies suggest that it is not only wacky 19th century treatments that can foster a placebo effect, but also modern medicine's sophisticated technology, including the most concrete of medical tools, surgery. A Baylor School of Medicine study published in 2002 in the New England Journal of Medicine evaluated surgery for patients with severe debilitating knee pain. The lead author of the study, Dr. Bruce Moseley, knew that knee surgery helped his patients. All good surgeons know there is no placebo effect in surgery. But Moseley was trying to figure out which part of the surgery was giving his patients relief. The patients in the study were divided into 3 groups. Moseley shaved the damaged cartilage in the knee of one group. For another group, he flushed out the knee joint, removing material thought to be causing the inflammatory effect. Both of these constitute standard treatment for arthritic knees. The third group got fake surgery. The patient was sedated. Moseley made 3 standard incisions and then talked and acted just as he would have during a real surgery. He even splashed salt water to simulate the sound of the knee washing procedure. After 40 minutes, Moseley sewed up the incisions as if he had done the surgery. All 3 groups were prescribed the same post-operative care, which included an exercise program. The results were shocking. Yes, the groups who received surgery, as expected, improved. But the placebo group improved just as much as the other 2 groups. Despite the fact that there are 650,000 surgeries yearly for arthritic knees, at a cost of about $5,000 each, the results were clear to Moseley. My skill as a surgeon had no benefit on these patients. The entire benefit of surgery for osteoarthritis of the knee was the placebo effect. Television news programs graphically illustrated the stunning results. Footage showed members of the placebo group walking and playing basketball, in short, doing things they reported they could not do before their surgery. The placebo patients didn't find out for 2 years that they had gotten fake surgery. One member of the placebo group, Tim Perez, who had to walk with a cane before the surgery, is now able to play basketball with his grandchildren. He summed up the theme of this book when he told the Discovery Health Channel, "In this world, anything is possible when you put your mind to it. I know that your mind can work miracles." Studies have shown the placebo effect to be powerful in treating other diseases, including asthma and Parkinson's. In the treatment of depression, placebos are stars. So much so that psychiatrist Walter Brown of Brown University School of Medicine has proposed placebo pills as the first treatment for patients with mild or moderate depression. Patients would be told that they're getting a remedy with no active ingredient, but that shouldn't dampen the pill's effectiveness. Studies suggest that even when people know they're not getting a drug, the placebo pill still works. One indication of the power of the placebo came from a report from the United States Department of Health and Human Services. The report found that half of severely depressed patients taking drugs improved versus 32% taking a placebo. Even that impressive showing may underestimate the power of the placebo effect, because many study participants figure out they're taking the real drug because they experience side effects that are not experienced by those taking the placebo. Once those patients realize they're taking the drug, i.e., once they start believing they're getting the real pill, they are particularly more susceptible to the placebo effect. Given the power of the placebo, it is no wonder that the $8.2 billion antidepressant industry is under attack by critics who charge that drug companies are hyping the effectiveness of their pills. And in a 2002 article in the American Psychological Association's Prevention and Treatment, The Emperor's New Drugs, University of Connecticut psychology professor Irving Kirsch found that 80% of the effect of antidepressants as measured in clinical trials could be attributed to the placebo effect. Kirsch had to invoke the Freedom of Information Act in 2001 to get information on the clinical trials of the top antidepressants. These data were not forthcoming from the Food and Drug Administration. The data show that in more than half of the clinical trials for the 6 leading antidepressants, the drugs did not outperform placebo sugar pills. And Kirsch noted in the Discovery Health Channel interview that the difference between the response of the drugs and the response of placebo was less than 2 points on average on this clinical scale that goes from 50 to 60 points. That's a very small difference. That difference clinically is meaningless. Another interesting fact about the effectiveness of antidepressants is that they have performed better and better in clinical trials over the years, suggesting that their placebo effects are in part due to savvy marketing. The more the miracle of antidepressants was touted in the media and in advertisements, the more effective they became. Beliefs are contagious. We now live in a culture where people believe that antidepressants work, and so they do. A California interior designer, Janice Schofield, who took part in a clinical trial to test the efficacy of Effexor in 1997, was just as stunned as Perez when she found out that she had been on a placebo. Not only had the pills relieved her of the depression that had plagued her for 30 years, the brain scans she received throughout the study found that the activity of her prefrontal cortex was greatly enhanced. Her improvements were not all in her head. When the mind changes, it absolutely affects your biology. Schoenfeld also experienced nausea, a common Effexor side effect. She is typical of patients who improve with placebo treatment and then find out that they are not on the real drug. She was convinced the doctors had made a mistake in the labeling, for she knew she was on the drug. She insisted that the researchers double-check their records to make absolutely sure she wasn't on the drug. Nocebos, the power of negative beliefs. While many in the medical profession are aware of placebo effect, few have considered its implications for self-healing. If positive thinking can pull you out of depression and heal a damaged knee, consider what negative thinking can do in your life. When the mind, through positive suggestion, improves health, it is referred to as the placebo effect. Conversely, when the same mind is engaged in negative suggestions, that can damage health, and negative effects are referred to nocebo effect. In medicine, the nocebo effect can be as powerful as the placebo effect, a fact that you should keep in mind every time you step into a doctor's office. By their words and their demeanor, physicians can convey hope-deflating messages to their patients, messages that are, I believe, completely unwarranted. Albert Mason, for example, thinks his inability to project optimism to his patients hampered his efforts with his ichthyosis patients. Another example is the potential power of the statement, "You have 6 months to live." If you choose to believe your doctor's message, you are not likely to have much more time on this earth. I have cited the Discovery Health Channel's 2003 program, Placebo, Mind Over Medicine, in this chapter because it is a good compendium to some of the medicine's most interesting cases. One of its more poignant segments feature a Nashville physician, Cliff Madar, who has been reflecting on the potential power of the nocebo effect for 30 years. In 1974, Madar had a patient, Sam Lunday, a retired shoe salesman suffering from cancer of the esophagus, a condition that was at the time considered 100% fatal. Lunday was treated for that cancer, but everyone in the medical community knew that his esophageal cancer would reoccur. So, it was no surprise when Lunde died a few weeks after his diagnosis. The surprise came after Lunde's death, when an autopsy found very little cancer in his body, certainly not enough to kill him. There were a couple of spots in the liver and one in the lung, but there was no trace of the esophageal cancer that everyone thought had killed him. Madar told the Discovery Health Channel, "He died with cancer, but not from cancer." What did Lunde die of if not esophageal cancer? Had he died because he believed he was going to die? The case still haunts Madar, 3 decades after Lunde's death. "I thought he had cancer. He thought he had cancer. Everybody around him thought he had cancer. Did I remove hope in some way?" Troublesome nocebo cases suggest that physicians, parents, and teachers can remove hope by programming you to believe you are powerless. Our positive and negative beliefs not only impact our health, but also every aspect of our life. Henry Ford was right about the efficiency of assembly lines, and he was right about the power of the mind. If you believe you can, or if you believe you can't, you're right. Think about the implications of the man who blithely drank the bacteria that medicine had decided caused cholera. Consider the people who walk across coals without getting burned. If they wobble in the steadfastness of their belief that they can do it, they wind up with burned feet. Your beliefs act like filters on a camera, changing how you see the world, and your biology adapts to those beliefs. When we truly recognize that our beliefs are that powerful, we hold the key to freedom. While we cannot readily change the codes of our genetic blueprints, we can change our minds. In my lectures, I provide 2 sets of plastic filters, one red and one green. I have the audience pick one color, and they'll look at a blank screen. I then tell them to yell out whether the image I project next is one that generates love or generates fear. Those in the audience that don the red belief filters see an inviting picture of a cottage labeled House of Love. Flowers, a sunny sky, and a message, "I live in love." Those wearing the green filters see a threatening dark sky. Bats, snakes, a ghost hovering outside a dark, gloomy house, and the words, "I live in fear." I always get enjoyment out of seeing how the audience responds to the confusion when half yell out, "I live in love," and the other half, in equal certainty, yells out, "I live in fear," in response to the same image. Then I ask the audience to change to the opposite colored filters. My point is that you can choose what you see. You can filter your life with rose-colored beliefs that will help your body grow, or you can use a dark filter that turns everything black and makes your body and mind more susceptible to disease. You can live a life of fear or live a life of love. You have the choice. But I can tell you that if you choose to see a world full of love, your body will respond by growing in health. If you choose to believe that you live in a dark world full of fear, your body's health will be compromised as you physiologically close yourself down in a protective response. Learning how to harness your mind to promote growth is the secret of life, which is why I called this book The Biology of Belief. Of course, the secret of life is not a secret at all. Teachers like Buddha and Jesus have been telling us the same story for millennia. Now science is pointing in the same direction. It is not our genes, but our beliefs that control our lives. Oh, ye of little belief. That thought is a good entry into the next chapter, in which I'll detail how living in love and living in fear create opposite effects in the body and the mind. Before we leave this chapter, I'd like to emphasize again that not only is there nothing wrong with going through life wearing the proverbial rose-colored glasses. In fact, those rose-colored glasses are necessary for your cells to thrive. Positive thoughts are a biological mandate for a happy, healthy life. In the words of Mahatma Gandhi, your beliefs become your thoughts become your words become your actions become your habits become your values become your destiny.